Polynomial inequalities, and this time we want to solve by graphing. I've already done a video on how to solve these with sign charts, but this time we're going to look at graphing. And the first thing you want to do in solving this inequality is you want to make sure you have 0 on one side. So here in example 1, I want to solve 3 times x squared minus 1, x minus 2 quantity squared, times x plus 4 greater than or equal to 0. And so I've already gotten 0 on one side of my inequality. That part is done. The second thing you want to do is to factor. And this thing is almost factored for us. The only thing I need to worry about here is that x squared minus 1 factors as the difference of two squares. X plus 1 times x minus 1. And then I have x minus 2 squared times x plus 4 greater than or equal to 0. And there it is. Okay, so from here, I can now just try to factor this expression, this polynomial. And what I'm asking myself at this point, I'm asking for what values of x is this polynomial greater than or equal to 0. So in other words, when is it 0 or positive? Okay, so and we can see that in the graph. All right, so let's graph this thing. Now there are two key ingredients to graphing a polynomial. The first one would be finding my x-intercepts and their multiplicities, and I'm going to do that with a chart here. Okay, so I can see from my factored form, I have, because of the x plus 1, if x equals negative 1, I have a 0. So I can see that I have a x-intercept at negative 1, and its multiplicity is 1. The multiplicity is how many times that factor shows up in my factoring. Now for x minus 1, that gives me a 0 of positive 1. I give it a multiplicity 1. X minus 2 gives me a x-intercept of 2, but because of this squared exponent here, that means I have a multiplicity 2 at x minus 2. And then finally I have negative 4 with a multiplicity of 1. So I'm going to mark these 4 spots on my x-axis. I have negative 4 here, negative 1, positive 1, and positive 2. Alright, so there I have my intercepts and my multiplicity. The second thing we have to worry about here is called the behavior. And the behavior says what happens as x goes to positive and negative infinity. In other words, on the outsides. Okay, so if I were going to multiply all of this out, you'd have to do a lot of foiling and combining like terms and things like that. But the very first thing you would write would be 3 times x times x times x squared times another x. So let's see, what would that be? That would be a 3, 1, 2, 3, 4, 5, x to the 5th plus some stuff. The other stuff doesn't really matter here for in behavior. That first term, the x to the 5th, does. What that tells me is that since the leading coefficient's positive on my in behavior, on the right hand side, I'm going to go up. So here at 2, I'm going up like this. And because it's an odd degree, it's an x to the 5th, that means my left hand side is going to go opposite. It's going to go in an opposite direction. So it's going to go down like that. Okay, so that's my in behavior. And I went through that kind of quickly. I have a video covering how to graph polynomials, and it talks about multiplicities and in behavior, and you can see that as well. Okay, now where the multiplicities come in play is that in the middle, if I have an odd multiplicity, so at these 3 places, then the line just crosses the graph, no big deal. If I have an even multiplicity, like I do at 2, then it's going to hit the graph, then bounce. So what that tells me then is that negative 4, since I had a multiplicity of 1, it's going to go up. At negative 1, it's going to pass through again. At 1, it's going to pass through. And at 2, it's going to bounce and go up. And my polynomial looks kind of like this. Now, it may be that I got some of these hills either exaggerated or need to exaggerate them more. For our purposes, that doesn't really matter. Because again, what are we trying to figure out? Back at the beginning, we said we're trying to figure out when this polynomial is greater than or equal to 0. So in other words, is this thing greater than or equal to 0? When is it equal 0? And when is it greater than 0? Okay, so it's equal at 0 at the intercepts, right? I mean, that's what's special about the intercepts. Now, when is it greater than 0? When it's above the x-axis. So we can see from there to there, there to there, and on. That's where it's greater than or equal to 0. So as a solution to this inequality, I could write from the graph, I see that it's going to be from negative 4 to negative 1, 1 to 2, and 2 to infinity. Now how do I lace these up? Because I have equal to, I put hard brackets where it's appropriate. And that includes those places. Now remember, infinity never gets a bracket. It's always in parentheses, so I don't put in a bracket on that. Now one thing I can think about for a second is, wait a minute, The hard bracket means those numbers are included, which means 2 is included here and in here. So there's no real reason to bring those together. My real answer would look like this. -4 to -1 and 1 to positive infinity, right? Because it never dips below the x-axis from 1 onward. And that is my answer. Let me show you one more, and hopefully this is making sense. Okay, now in example 2, we want to solve x cubed plus 5x squared minus 4x by graphing. And this time, I don't have a 0 on one side of my equation. So remember, I need to get 0 by itself. So I'm going to have x cubed plus 5x squared. Let's bring over to get a plus 4x less than 0. From there, remember, once I get a 0 on one side, I need to factor. And here I can factor by taking an x out of everything. And when I do that, I have x squared plus 5x plus 4. And I can factor that as well, because two things that multiply give me 4 and add to give me 5. How about 4 and 1? Okay, and there it's factored. Now I'm ready to graph. And let's see if we can do this quickly. So I see here I have zeros at 0, -4, and -1. So that's 0. Let's say that's -1 here, and -4, something like that. I also know that when I multiply all this out, we would get back up to here. And so I can see that this is a x cubed, a cubic polynomial, we say. So from the behavior, on the right-hand side, since I have a positive leading coefficient, it's going to go up. It's going to do something like that. And because the degree is odd again, I'm going to end up on the opposite side. Now in the middle, all of my x-intercepts have a multiplicity of 1. So that means it's always passing through something like this. And so there's a rough sketch of my polynomial. And now we're ready to solve, because what are we looking for? We're looking for when is this thing less than 0, and which means negative, and I can see from my graph that it's going to be less than 0 from there, not at -4 because it hits 0 at -4, same with -1 and 0, not at those places, but in between. So as a solution then, I could write -infinity to -4, or my x's make this polynomial below 0, and from -1 to 0, and I'll put parentheses on both of those and get a union. And there's my solution. Some textbooks like using sign charts. It takes everything purely in the algebra world, and I think it's a good technique. Some books like to show by graphing because it puts it more in a geometric perspective, and I think that's a good technique as well. Make sure you learn the technique that you're supposed to learn, and it doesn't hurt to know both. If you have any questions on this, I'd be glad to help, and thank you for watching.